All right, so here's one of your questions on homework assignment 7A. It says Titan with a radius of 2.58 times 10 to the 6 meters is the largest moon on planet Saturn. If the mass of Titan is 1.35 times 10 to the 23 kilograms, what's the acceleration due to gravity on the surface of the moon? So this relates to something I talked about at the end of last period of Wednesday's class. So if you look at the recording, you'll see that there. We talked about how one way to calculate the gravitational force is this way, the universal law of gravity that we learned here. But we also got the old way, and it's still legit. There's nothing wrong with the old way, is that another way to do it is to take the mass of your object and multiply it by the gravitational field. Both of them are ways to calculate Fg. And if we set those two equal to each other, because they're both equal to Fg, that's going to give us some more information here, which is the mass of the object cancels out in this thing, and then we got basically this equation that shows up as a result. So you got baby g, that's the gravitational field, or the acceleration due to gravity, right? I've been saying you can interchange those things basically, especially on the surface of whatever planet you're on. It'd be equal to the gravitational constant, that's 6.67 times 10 to the negative 11 newtons meters squared divided by kilograms squared, multiplied by the mass of whatever celestial body is generating that electric field. So it's the mass of that, sorry, not electric field, that gravitational field. And then d squared, in this class, d is always going to be the radius of the celestial body for this particular equation, where d over here, and you know what, in fact, I think I'm just going to replace this. This isn't going to be d anymore. I'm just going to call it r. That's just going to confuse people. So we'll say r squared right there. Okay, so I can use this equation now to solve this particular problem. So I got the radius of Titan is 2.58 times 10 to the 6 meters. And then the mass of Titan is equal to 1.35 times 10 to the 23 kilograms. And then, so the question is, what's the acceleration due to gravity, baby g, or the gravitational field? They could have asked either or. It'd be the same thing. And I also know that big G is 6.67 times 10 to the negative 11 newtons meters squared over kilograms squared. So using this equation, right, there we go, G is equal to big G times the mass of the source, so that'd be the mass of Titan, divided by the radius of Titan squared. I can then just plug all this stuff in here. So it's going to be G equals 6.67 times 10 to the negative 11. The mass is 1.35 times 10 to the 23 kilograms. And then divide all that by r squared. That's going to be 2.58 times 10 to the 6. All of this is squared. Don't forget to square all of that. When I plug this into my calculator, I like to let's see. Yeah. I like to do the squared first. So I'll do 2.58 times 10 to the 6. All that squared. And then I'll divide that by everything else. So we got 6.67 times 10 to the negative 11 multiplied by 1.35 times 10 to the 23. And then take all of that and divide it by my answer. And I'm getting 1.35. So 1.35. And I could say newtons per kilogram, or they're saying the acceleration due to gravity, so odds are you would want to have meters per second squared. If you check, the units will check out as well. But I want to keep this video short. So there you go. Hopefully that helps. Thank you. Bye.